Hi there, folks. Today we're going to be talking about Module 1 problem solving. This is just going to be a brief introduction, though. And so, when we think about problem solving is a subject which we all inherently understand. When there's a problem, how do we approach solving it? This could be any of a variety of problems. So, and again, when we're thinking about mathematics, we tend to focus more on math word problems, but we don't really need to worry about how Lex Luthor got those 40 watermelons or whatnot. And so we're more interested in, can we actually do some real world problems? One of the simplest examples is building a birdhouse. And so if you wish to build a birdhouse, what material are you going to need? How much material? How much will it cost? Those are the types of big real world questions that we're going to be dealing with. No matter what field you're in, you're going to be encountering problems, and being able to solve those problems is going to be very useful. Now, to begin with, there are two types of reasoning which we're going to focus on in this course. There is inductive reasoning, which is the process of reasoning that arrives at a general conclusion based on the observations of specific examples. This is pattern recognition, also the scientific method, where we are creating a prediction and then trying to see if the prediction actually works out. A mathematical example might be when we look at prime numbers, they seem to all be odd. So a conjecture could be that they are all odd. Of course, that conjecture is false because 2 is an example of a prime number which is not odd. All of the other ones are odd, but 2 is not. Inductive reasoning is something which we are all trained to do. The idea of looking for patterns, it's built into us. That's how we have come to be as a people. And so it's very important that we have that tool. But there is another tool or another type of reasoning which we have. And this one is much more mathematical. I often think of this as the mathematical method as opposed to the scientific method. Deductive reasoning is the process of reasoning that arrives at a conclusion based on previously accepted general statements. It's based on overall rules, not specific examples. The idea here is we define objects and then we create conditional statements based off of those definitions. And we're able to kind of build a world based on those. And so, for instance, we define what a number is. And so we define the number 1, define the number 2, and so on. We define addition, and then we can build all of the rest of the numbers. We can then do the same to build the idea of shapes, and really our entire mathematical conscience is based on this idea of deductive reasoning. An example, an odd number is defined to be a number which is of the form 2n plus 1 for some integer n. We can conclude that no odd number is evenly divisible by 2, because there will always be a remainder of 1. That second statement is based on the first statement. And this idea of building this chain of logic is what deductive reasoning is all about. Another problem-solving tool is estimation. And so in the days of smartphones and calculators, estimation is becoming a lost art. But being able to ballpark a solution is a great tool to have. Whether you're approximating costs or cooking or trying to wrap a Christmas present, being able to measure in a way which is close is very useful. A related approach is to try a simpler problem. If you're dealing with a problem which has mean numbers, variables, or etc., try simplifying it by using nicer numbers. You can then go back and do the same process with the messy numbers, but doing it with the easier ones will give you a roadmap. These are two approaches which are very, very useful. Again, they're not going to give you the exact answer, but at least you'll have some idea of what the right answer should be. Oftentimes, that's going to be sufficient. If you don't know if you're going to need a 3-foot board or a 4-foot board, but you know it's going to be roughly around there, when you go to the store to buy boards, if you purchase a 6-foot board, you're going to be more than good. And so estimation will often be a great tool for figuring out whatever problems you're going to have. We also have problem-solving strategies. There are a lot of problem-solving strategies out there. The four-step problem-solving strategy is a fairly common one, though. Step one, understand the problem. This is a very important step. If you don't understand what's going on, then the rest of the steps are useless. But once you have a good understanding of the problem, you can devise a plan to solve the problem. Step three, carry out your plan to solve the problem. And step four, check your answer. Always check your answer. Even if your check is just to do a little estimation, you always want to know if your answer sounds reasonable. Here's a few pro tips. Draw a diagram. When in doubt, draw a diagram. Even if it's just a little goofy picture, it'll often help. Guesstimate. If you are not even close to knowing where to start, just try and guess around and see if you can figure anything out. If things go wrong, double check your algebra. I mean, oftentimes that's going to be where folks make the mistakes. And so always double check. And then if it's okay if things do go wrong, take a breath, go at it again. One of the nice things about a math course like this is it's very low stakes. Uh, Doing stuff wrong here isn't going to make or break things. It'll affect your grade a little bit, but that's small potatoes compared to some of the life or death things that you'll be doing in the real world. And so we want to make sure that you are figuring out how to solve the problems now. That said, that brings us to the end of our brief introduction. Module 1 is problem solving, and I wish you all good luck, folks.